far, every time we've talked about trig functions, we've referred to angles as acute. And this was important because we were dealing with triangles. And, well, if we have one angle that's already 90 degrees, we can't have anything other than an acute angle in this triangle. But now we're going to expand this to talk about all angles. We'll now consider a generic angle theta that's in standard position and has the point AB somewhere on the terminal side. And the only real condition for this point is that it's not 0, 0. Any other point on that terminal side is fine and will work. In this case, A, the first coordinate, acts just like your adjacent side length. And B, the second coordinate, acts just like the opposite side. Opposite. Your hypotenuse is going to then be given by the Pythagorean theorem, the square root of a squared plus b squared. And using this, we can find all of our trig values. Let's now consider an angle with 4, -3 on the terminal side, and we want to find all 6 trig functions. In this case, the 4 is the adjacent and the -3 is the opposite. If you have a hard time remembering that, just remember that it's always in alphabetical order. Your hypotenuse, on the other hand, comes from the square root of 4 squared plus -3 squared. This is 16 plus 9, which is the square root of 25. So the hypotenuse is 5. Now sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And then finally, cotangent of theta is adjacent over hypotenuse, adjacent over opposite. So now we have all 6 of our trig functions. And the main difference between this and what we've been doing is now you'll see that negative values are possible in this case. Let's now think of some particular angles. We'll start with 0, which is just the x-axis, and we know a point on there is 1, 0. So now if I try to find these, first we'll find our hypotenuse, which is the square root of 1 squared plus 0 squared, which will be 1. So sine is opposite over hypotenuse, which is 0. Cosine is adjacent over hypotenuse, which is 1. Tangent is opposite over adjacent, which is 1, or 0 rather. Cosecant of theta is hypotenuse over opposite, and since we can't divide by 0, we just say that this value does not exist. Secant is then adjacent over hypotenuse, which is also 1. And then cotangent is adjacent over opposite, which once again divides by 0. So cotangent of 0 does not exist. Next, we'll consider 90 degrees or pi over 2 radians. And we'll note that 0, 1 is a point on that terminal side, on the y-axis in this case. We also once again need to find the hypotenuse, which will be the square root of 0 squared plus 1 squared, which is just 1. For sine, I have opposite over hypotenuse, which is 1. Cosine is adjacent over hypotenuse, which is 0. Tangent, opposite over adjacent, which is dividing by 0, so that does not exist. Cosecant of theta is hypotenuse over opposite, which is 1. Secant of theta is hypotenuse over adjacent, which is dividing by 0, so that does not exist. And then finally, cotangent of theta is adjacent over opposite, which is 0. So now I have all 6 for both 0 and 90 degrees. Next, we'll consider 180 degrees, which is a straight angle. So we have a point on the terminal side like -1, 0. And once again, you can double check, but the hypotenuse will be 1. So sine of theta, adjacent over hypotenuse, which is 0. Cosine of theta is adjacent over hypotenuse. Sorry, sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse, which is 1. Tangent is opposite over adjacent, which is 0. Cosecant of theta. Cosecant will be hypotenuse over opposite, which in this case does not exist. Secant will then be hypotenuse over adjacent, which is -1. And then finally, cotangent is adjacent over opposite, which does not exist here. So now we have 180 degrees as well. The next thing we'll look at is coterminal angles. Coterminal angles are angles that have the same terminal side. And this is very helpful because their trig values will also be the same. If I try to find cosine of 390, we know that 360 is all the way around, and then we need to go an extra 30. So this is the same thing as cosine of 30 degrees, which we already know to be √3/2. Next, we'll look at sine of 420 degrees. Once again, a full circle is 360, and to get to 420, this time we need to go up an additional 60 degrees. Therefore, this is the same thing as sine of 60 degrees. And we already know that that is once again the square root of 3/2. Next, we have cotangent of 9π/4. A full circle is 2π, which is the same thing as 8π/4. And then we need to go up an additional π/4. So this will be the same thing as cotangent of π/4, which we know is 1. Cosecant of -7π/4. Once again, we know that 8π/4 is a full circle. The negative means we're moving around clockwise. So this is the same thing as cosecant of π/4, which we know to be the square root of 2. Finally, secant of -270. -270 goes around clockwise and is the same thing as secant of 90 degrees, which we have found actually does not exist.